Alrighty. So here's the two things we've learned for quadratic functions so far. This form right here on the left, vertex form. This one, standard form. Axis of symmetry. Remember, this means it moves it 3 places to the right, so that's going to cut it down the middle. X equals 3, your vertex. It's going to be on that axis of symmetry up 2 because you move the parabola up 2 places. And then if you just go through there, your parabola or quadratic function has a oh goodness. Sorry, didn't mean to be yawning so much. A vertical stretch of a half by a factor of a half, so and it opens up because it's positive. So we're going to go up a half. Oops. Instead of up 1 when I move over 1. And then I'm usually over to the right 2 and up 4, so I'll be over to the right 2 and up 2. And that looks good enough. Okay, so we got that. We could talk about domain and range. The domain of this is all real numbers. I can plug anything in the world into that. But the range is going to be only y is greater than or equal to 2. We discussed, let's see, this one has a minimum value of 2 when x is 3. Right here it's decreasing, right here it's increasing from left to right. So we've talked about all these things, so this is good. Standard form, remember your axis symmetry, you figure out x is the opposite of b over twice the a. Negative 8 over negative 8 is 1. So axis of symmetry right there at 1. When you plug 1 in, negative 4 plus 8 plus 2, it's going to be at 6. So 1, 2, 3, 4, 5, 6. So I've got an axis of symmetry at x equals 1, a vertex at 1, 6. Ooh, I have a y-intercept at 2. Got a vertical stretch of 4, and it was reflected over the x-axis, so it's going upside down. And then, let's say I want to plug, let's plug a negative 1 in. So there's negative 4 minus 8 plus 2, what's that going to be, negative 10? So if I plugged in negative 1, I'm all the way down here. Okay, so I'm just going to say a bunch of this stuff instead of writing it down. Oh gosh, didn't go through the point. Not even close. Oh, it looks like it comes to, looks like it's a pointy thing. It's not, it's a curve. So I've got a maximum value of 6 when x is 1. It's decreasing to the right of x is 1. It's increasing to the left of x is 1. We've got a y-intercept of 2. Like we got all this. So we got the two different forms. Oh, and we already talked about that. Find the y-intercept of each. Of course, granted, I've got points most of the time, but remember, y-intercepts, anytime you're doing a y-intercept, here's an x, here's a y, the y is 0. So if I go back to that first one and say, okay, what's my y value when I plug a 0 in for x? What's that going to be? Half of 9 minus, or plus 2, so that's 4 halves. So had I found the y-intercept, it would have been at 13 halves, which is 6 and a half. So 1, 2, 3, 4, 5, 6, and then halfway. So then I could add a little bit better sketch. This one we already know from yesterday because I plug a 0 in for x, makes those disappear. So the y-intercept here is at 0, 2. Now, the big thing about y-intercepts, remember, to find a y-intercept, we let the x be 0. Because when you grab something, if it crosses the y-axis, you didn't go left or right any. It's just sitting there at the x value 0. So how would we find an x-intercept? Well, that means that point isn't up or down any, so it has a y value 0. So back in Algebra 1, like we got a lot of stuff going on right here at once. Back in Algebra 1, y'all learned how to solve things like this. Like they're already in factored form. How could I solve it? Because when you put things in factored form, it's something times something times something times something. Like if you multiply a bunch of stuff out and you get a 0, it's because one of those numbers at least was 0. So factored form was really nice back in Algebra 1. You got a -8 times x minus 3 times x plus 7 times x minus 9. Now you could look at it as -8x times all this, but let's say I broke it down into its most basic components. So you got -8 times something times something times something times something all equals 0. Well, that's not the one that's 0. -8 is -8. But what makes that just plain old x 0? 0. If x were 0, this whole thing would multiply out to be 0. What makes this one, the x minus 3, 0? 3 does. What makes x plus 7, 0? -7 does. What makes x minus 9, 0? 9 does. So y'all learned how to solve equations that were factored. We're going to use that same idea today. Okay. So there's going to be a third form of a parabola. And we call it intercept form. Because they're going to write, okay, so remember vertex form is this. To me, absolutely the most useful. If I've got to pick a form, that's the form I'm getting in. Because you get the vertex and axisymmetry sitting there. Standard form, that. And now we've got intercept form, which, see, they all have the A out front, but it's just going to be something in factor form. It's not, I personally don't think it's all that important that you know this P and Q business. We'll talk about, I took the little part from the book so we can show you what they're doing with the P and the Q. But see how this would multiply out to be, let's see, x squared minus x plus 3x. So plus 2x minus 3. So I could rewrite it in standard form as that. But the form it's in right now is awful handy because if I did want to just look at it and say, okay, what if I set it equal to 0? Then the x values that make this equal 0 are -3 and +1. So if I go to -3 and +1, those are the x-intercepts. Because that's when the function equals 0. And f of x works like a y. That's when I let the y equal 0. If y equals 0, you're on the x-axis. So there's your x-intercepts. Now, I could also get the y-intercept real easily because I could let x be 0. So -2 times 3 times -1, what is that, 6? So right up here at 0, 6 is going to be a y-intercept. Now you can tell, and you know, because that's negative, it's going to open down. But the thing about a parabola, there's a line that cuts through the middle where everything is symmetrical about it. So if these are the two x-intercepts, if you could find the number halfway between -3 and 1, you'd have your axis of symmetry. It's got to be doing this. So that halfway between is cutting down the middle. Well, how do you get halfway between two numbers? You average them off. So right there at -1, we've got ourselves an axis of symmetry. And then we could find that vertex by going up here and plugging in the -1. And it's going to sit right there at -1, 8. Axis symmetry, x equals -1. And that's really messy, but sometimes just learn how to do it, I think. It's okay to be a little messy because we're just talking. Okay. All right, let's try another one. Ooh, what about this? Well, this one had 2 different x-intercepts. That's the same thing as x plus 4 times another x plus 4. So if I were to set that equal to 0, the only x value that makes that equal to 0 is x is -4. So, if it only has one x-intercept, that means it has to just touch the x-axis right there. And it's going to open up. We can get a y-intercept. Ooh, it's going to be way up there. It's going to be all the way up at 48. So let's make this look. So right here at -4, we're going to just touch the x-axis. Way up here at 48, we're going to cross the x-axis. And here's the thing, if it just touches right there, that's got to be the middle of it. Because there's going to be another point over here that lines up. So x is -4. It's got to be the axis symmetry. There's the vertex. There's going to be a point right here. It's not 0. If it was a distance of 4 here, it's going to go 4 there. That's going to be at -8, 48. I probably should have lined that up here too. Like if you get that point 0.6, then right there, if it was 1 to get to there, it's going to be 1 to get to here. That's going to be at -2.6. Okay. And you can find other points all the way. Like I could plug in -3, -2, -1. But there's the gist of it. Okay. All right, so this one. When does that equal 0? At -5 and -1. It opens down. It's just a regular old size one. What's halfway between -5 and -1? -3 is. So that's going to cut it down the middle. If I plug in -3, we'll be up 4. There's the vertex. If I want to get the y-intercept, I'm going to plug in x is 0. It's going to be at -5. It's probably a little too far down there. And I can line a point up with that point. So if -3 is right there in the middle, 3 this way, 3 that way, that makes that at -6. Here's the axis symmetry. Gosh, that's messy. So that's another form. That's pretty handy. What they're saying in the book is they're with the P and the Q is x minus some number, x minus some number. If you figure out what those numbers are, then we just average them off. But yeah, that's what I did too. I figured out where they were, and I averaged them off and got what was in the middle. Okay, and then one other thing is, can you determine whether or not a quadratic function can be written in intercept form simply by the graph? Because we can only, like, this thing's giving us x-intercepts. So what if you've got some parabola that opens up and it sits right there? Is it ever going to cross the x-axis? No, that thing can't be written in intercept form. However, if you had the same vertex and the same axis of symmetry and it opened down, then you could write it in vertex form because it would cross the x-axis and hit it 2 times. If you've got that, it's only going to have 1 x-intercept. But you could write that in intercept form. That would only have 1 intercept. If you were down here someplace, open and down, it's not going to have any x-intercepts. You can't write it in intercept form. If it were down there somewhere like the vertex was and it opened up, then it would have 2 x-intercepts. So you could write that in intercept form. Okay? And then just this idea of intercept form, sometimes it just makes life a little easier. So we've got a woodland jumping mouse hops along a parabolic path. So it's like it's hopping. And the hop is shaped like a parabola, given by this equation. Okay, where x is the horizontal distance traveled in feet. Okay, so we're in distance traveled. So the horizontal distance traveled in feet, and y is the corresponding height of the jump in feet. Now notice I only did the first quadrant because those 2 things are going to be positive numbers, a distance and a height. And I could take and factor out an x. And actually, I could factor out more than that if I wanted to. If I wanted to factor out a negative x, I could do that. And that would leave what? 0.2x minus 1.3. So if you're saying, okay, when does that equal 0? That's 0. And when does this equal 0? Let's multiply both sides by 10. X is 13 halves, which is over here at 6.5. And it's a downward facing parabola. Let's see what we know. Can the mouse jump over a fence that's 3 feet high? Well, let's look at this. Right there, halfway between those 2 points has to be the vertex. So 3.5. So half of 6.5 is what? 3.25? Well, let's see how high it can jump then. Let's see what we get when we plug in 3.25. Oh, I don't feel like doing this by hand. I don't have my calculator out. Ugh, I have to use the phone calculator. Let's see, 3.25. Square that, multiply it by 0.2. All right, so here's negative 2.1125 plus 1.3 times 3.25. Okay, that x got out this y. So at 3.25 feet, it's that many feet high. The question was, can it jump over a fence that's 3 feet high? Well, that's the maximum height that's ever going to be. No, it can't jump over a fence 3 feet high because it never gets any higher than that. Okay. All right, next one. The parabola shows the path of your first golf shot, where x is the horizontal distance in yards and y is the corresponding height in yards. The path of your second shot, okay, so second shot is this. Which shot travels farther? Okay, so if I were to graph this one, what makes that equal 0? 0 at 80. So we've got something else like this. So which one traveled farther? So this is the first shot over here, second shot over there. This one definitely traveled farther first shot. It was 100 versus 80. Okay. Got that before hitting the ground. Which one traveled higher? Okay, well this one traveled, it got to a height of 25 feet. I guess it's feet. No, yards. Yards. This one, let's see how high it gets. So right halfway is going to be 40. That's going to be the maximum height when x is 40. So if I plug a 40 in, that's 2/100. Oh my gosh, my brain's not working this early in the morning. That's negative 0.8 times negative 40. Was that 32? Okay. So this one tops out at 32 feet. This one tops out at 25 feet. Which one traveled higher? Second shot.